So before diving in some of the features that function do have in Haskell, let me introduce you to arrays. And actually in Haskell, we don't really have arrays. We only have lists, but are morally the same thing. And we can create a list as we would expect in Haskell by using the square brackets and providing some values of the same type with commas in between them in order to distinguish them. And this is a valid syntax to create an array. But actually, in order to create an array, we do have only two functions, and those two functions are only made by symbols. One is the empty list, and this is a function which only returns the empty list. Or we have the colon, which in Haskell is sometimes called cons, which stands for constructor. And what it does, if I ask for the type of these cons, we see here that the cons is a function that takes anything and a list of the same anything and returns a new list of the same anything. And I say new because you have to remember that data is immutable in Haskell. So we are not really changing this list, but we are using the content of this list in order to create a new list. If we wrap the cons between parentheses, we are asking Haskell to first evaluate this, which results in this function. So we can use this as a normal function, and I can, as an example, provide an integer and then a list of integers, and this works fine. But of course, a more correct and also practical way to use the cons, since it is a symbol, we can use it in between the values it expects. So we are providing here a value and a list, and of course this can be a list with some values or without any values, still a list, and this will construct a list with the value we provided. And when writing something like this, what is going on here is doing something like this, and in which the expressions are evaluated in this order. So we are first inserting 3 into the list, then inserting 2, and then inserting 1. And of course, all these, as we saw above, can be written in one single statement by using curly brackets and providing directly the values. Now, I wanted to specify that you can construct a list using those two functions, since that concept is fundamental in order to understand how to iter over elements of a list. In fact, in Haskell, we don't really have loops, we do only have functions, but function can still be recursive. And in order to demonstrate how we can use recursion in order to iterate over the values of a list, let me define a simple function that I'll call addToOs, and all this function will do is taking a list of integers and returning a new list of integers with each values equal to the values we found in the input list, but added with a 2 just to do something. And I could define the add2 function like this. So it takes a list and then I use an if then else construct. And if you come from any programming language, this should not be anything new. And an if then else, of course, takes a boolean as first argument and then evaluates the first expression if this evaluates to a true, or evaluates the second expression if this evaluates to a false. And what I'm doing here is checking if the list is equal to the empty list. If that is the case, then we do not have anything to work with, so we just return the empty list. If that is false, so we do have some elements into the list, I use the add function in order to get the first element of the list. And as always, if you are not sure of what some code is doing, just go to GACI and ask for the type of head in this case. And we see that head is something that takes a list of anything and return one single element of anything. And even if after asking the type, the behavior is not clear, you can, as always, test the head with some input. And we see that we get the first element of a list, of course, as long as the list does have an element, or otherwise we throw an exception. In any case, here we are sure that we do have elements since we excluded the empty list case, so we can safely use the head function. And I want to provide to the head function the list as argument, which I got here as input. And remember that function are greedy, so this does have the precedence. So we here first extract the first value and then we add 2. Then I'm reusing the constructor in order to create a list and providing the freshly created value and adding it to the result of whatever is the result of add choose to the tail of the list. And once again, the tail is a function that given a list returns a list, and if we test this we see that all the tail is doing is just removing the first element and returning the rest of the list. So is the complementary function of head. And also in this case you have to be sure that you have some elements inside the list, since if you have at least one element then an empty list is returned, and when you have one element then add2 gets as an input one empty list, and the empty list returns an empty list. So this expression will be complete, and then we'll evaluate. If you stale with an empty list, once again, you get an exception, but this is not the case since we excluded it before. And of course, we can test this function with some input, and we see that it works as intended. But now let's dive in a little more in this function definition. In fact, we could define the same function in many different ways in Haskell. And one way would be to use the pattern matching feature of Haskell, which consists in, of course, defining a function, but then specify different ways with which a function will be substituted with, depending on how the parameters that function got have been constructed. And in this case, I can specify that when I choose pattern matching receives a list that has been constructed with the empty list constructor, then I want it to be substituted only with the empty list constructor. Otherwise, if the list that add to pattern matching was constructed using the const function, I want the add to pattern matching function to be substituted with this expression. And one advantage of using pattern matching is that I can assign names to the values that have been used with this specific constructor. And in this case, I'm assigning the list lm to the head. So we are directly accessing the first element and then calling the rest of the list, of course, rest of the list. And remember that this is a list, and eventually we could even use pattern matching once again, and this would still be valid. Of course, we don't need this in this case. And if you do that, remember that you should also have a case for when you have one single element inside the list. And of course, you can do that also by using pattern matching, but we don't need this in this case. And so when I do have a list that has been constructed with the const, so I do have at least one element, I want the add to pattern matching function to be substituted with the following expression. And so this definition is equivalent to the one we used before. This is the function defined with the if then else, or by using the add choose pattern matching. Well, of course, I have misspelled here, but that's not a problem. We see that still the value is evaluated in the same way. So in this video, we introduced list in Haskell and we saw how to construct lists using various methods. We also saw how to iter over lists, and we can do that by using a simple if then else construct, or by using the pattern matching by defining different expression to substitute a particular function with, depending on how the parameters passed have been constructed. In the next lesson, we are going to see some other function features that we can use in order to create function also from other function. If this video was useful to you, consider to subscribe to the channel. If you really want to support the creation of this content, you can delegate ADA to Harmonic pool, earning interest on top of supporting this series. But remember that in any case, the best thing that you can do is to always choose decentralization. In any case, I want to thank you for your time, and I will see you in the very next video. Bye bye.